We're here today at the Glendale Water Reclamation Facility. We're going to take a look at how our wastewater is handled. So sit back, relax, and join us in this science quest. We're here today with Bill Kruppa at the Glendale Wastewater Treatment Facility. Bill, why don't you give us a little lowdown of what's going on here?
Okay, well, I've broken it down into sort of 4 categories, but there's many ways to do that. There's a lot of other ways to take it down. We've got preliminary treatment, primary, secondary, and then chemical treatment. We don't do a lot of chemical treatment, but we do a little bit. So in the physical end of it, you see there's 2 different areas of physical. We have screening and grit removal. Our screens are 1/4-inch openings, which capture plastics and wood and all kind of things like that. And the grit removal is simply a vortex grit removal system. Throws the water and the sand outwards so that the sand will settle out in the grit. In the physical and the primary area, these are just tanks and equipment is what we're looking at. In the primary physical, what we do is we settle the solids that come in from the sewer system, and then we have floatables that come off the top. So the settling part of it is the sludge that we take to the digesters, which is over that area. Secondary treatment has to do with biological. We have activated sludge system, digestion, and clarification. Then we have the chemical treatment, which is in our thickening. So we take our material that we take from this area, thicken it with a polymer, which is an anion polymer, and it's a coagulant aid. And then the odor control, right now we're using bleach for odor control, and with air intermittent, and then chlorination on our final effluent. The final effluent from here goes to the large, I guess is a way to say it, 1,600-acre wetlands treatment system. They have overland treatment, and then pondage, which is evaporation and percolation. The reason we remove the grit and the screenings is because of the further tankage downstream in the equipment. If we left all the sand in there, it would be wearing our pumps out. It would be piling up in our primary physical settling and reduce our design capacity. With the settlables, which are solids, basically coming out, what we do is you bring the primary, you bring the solid, the flow itself into a quiescent state so that it will settle just by gravity.
Hold on a second. What is a quiescent?
A quiescent just means that we bring it to a still area. We slow the flow down into a large tank, which allows it to slow down and let the solids settle out by gravity. The solids that are brought out are brought over to our digestion system. We have a patented process that's called a thermophilic acid reactor, the first stage.
So nice big name. I think we're going to want to know what that is.
Okay, thermophilic just means high temperature. We have to hold the sludge, according to the patent, at 131 degrees for 3 hours. What that does is kill all the pathogens. The pathogens are diseased organisms.
Now, is that degrees Celsius or Fahrenheit?
That's Fahrenheit.
Okay, fair.
So once it goes through that one, then it goes to 2 other digestion tanks, which are mesophilic. That's 98 degrees, roughly our body temperature. There we grow what we call methane formers and acid formers. The methane formers we use to heat. In other words, they make heat, and we take that heat and heat up the first digestion system to the 131 degrees. Otherwise, we'd probably never be able to get up that high. Once it goes through there, then we haul it away from there by liquid trucks. Activated sludge system that we have is called an MLE, Modified Lutschag Ettinger System.
And that is?
And that is, That came from South Africa, actually. Dr. Bernard was the man that came up with the treatment process. All it is that we have the first 3 stages are they're actually anoxic, which means there's no air, basically. We really just mix it very gently. In those stages is where we do our biological nitrogen removal and our uptake on our phosphorus. Once it goes through those first 3 stages, then it goes through a regular activated sludge. All it means is that we're just treating it with air. We're doing the things that we would normally do to keep the bacteria and other organisms strong. Same as we have to have temperature, we have to have water, and we have to have air. So We supply air by three 450 horsepower blowers. That's what we use to get that air in there for them. The clarification part comes after the activated sludge. This again is a physical system, so it should be over here, but I put it here because it's right in direct relationship to the activated sludge.
Okay.
What it does again, quiescent, slows it down, lets gravity pull the sludge out of the bottom. And then that is also taken to the digestion system. Then from the digestion system, that sludge, I guess, again, is taken out by a truck hauler.
Right.
It takes it and uses it on sod farms and cow pastures, just anywhere that's legal,
okay,
according to DEP and EPA. In the chemical end of it, we have what we call thickening. We take the material that comes out of the clarification and thicken it with a polymer so that we get less water to haul, is about what it does. The odor control is a bleach solution. We have air that pushes it up through what we call saddles. They look like wiffle balls. That's what they look like. That's what I call them. So the contact between the water coming down and the air going up reduces the hydrogen sulfide content. And then the chlorination is just our final product, liquid product that leaves the plant. It goes down to the wetlands, which is, like I said, 1,600-acre wetlands treatment system.
Okay. Now, when you add the bleach for the odor control, is that having any negative effects on the water? Or?
No, it may lower the pH a little bit, but it doesn't affect it because it's really cleaning the air. So okay, so it's just a bleach solution. It doesn't affect our system. Actually, it helps. It keeps down some of the bad organisms that come in, filamentous organisms, which are very harmful to our digestion system and our activated sludge system.
Okay.
And I think that's all of as far as my basics of the four things that I would think to look at.
All right, so basically what you're saying here is we have a process. Now, would you mind simplifying it for our audience back at home?
Well, we'll give it a try. Let's see. First of all, the wastewater itself comes from the homes. That's where we get it in, and it comes through lift stations, goes into our preliminary area, which is the screening, which removes plastics and wood or anything else that might come in, dollar bills. We've had a few of those. And then it goes to the floating to the primary system so that it can come into that quiescent stage again that allows the settling and the floating to occur. We go into our biological treatment system, which is the activated sludge. We take that sludge, thicken it, so the process is sort of running through back and forth. We thicken it and we bring it back to digestion, and after digestion we remove it by liquid haulers right now. The clarified effluent, which is the final product, is clear, it's chlorinated, and then sent down to the wetlands treatment system for its final treatment part.
Oh, awesome. Well, Bill, this sounds like a great process. Is it all right if we go take a look at it?
Yes, we can go out and look at the tanks and, some equipment that we have, yes.
Awesome. I think that'll really put it in perspective then.
Good. Thank you. This is the first stage of the preliminary treatment system. This would be the screening area where we take out the plastics and all that. They come down and go on a conveyor to our back here, and it dumps into this machine. This piece of equipment is actually a dewatering equipment. It actually washes the sludge and the fines and whatever comes out, and then squeezes it down and squeezes the water out, and then dumps it into a dumpster that we end up taking to the landfill.
Okay.
Basically where that goes.
Now, before we go on to the next location, I have to ask, what's some of the strangest things that you found in the waste system here?
Well, before we had this crusher and the squeezers, is what we call a washer, we used to find dollar bills. We found hypodermic needles. We found $100 bills. As a matter of fact, one time, one of the guys was standing over here. But that's before we had all the newer equipment, and we were able to actually watch it coming off the screen.
Now you just have your garbage sausage maker.
Yeah, it just goes in there. Yeah, the garbage sausage maker, right.
All right, so tell me about where we're going next.
Okay, if we go over to our left, we'll go by the odor control system, and then we'll look at we'll just get a picture of the grit chamber. That's that bigger building over there behind the small one. Okay, over here is our odor control system. Any questions you might have at this point?
How's it work?
Well, we've got our bleach tank here, about 1,100 gallons total when it's full. That bleach is injected with water into a packed tower, which is over to our left, and they have these small, what we call wiffle balls, They're just to give contact for the water and the air to come in contact with each other and the hydrogen sulfide to be washed out.
All right, and so that's what's taking place over in this little washing machine?
Yeah, that's the actual
here?
bleach solution. That's the mixed solution. It's called a stilling well, basically
Okay.
what it is. But as you see the water coming down, you'll see the movement of the water coming down. That's the adducts of water that's being sprayed at the top of that tower.
All
Pack
right.
tower is what they call it.
Awesome. Well, this is very cool.
Coming up here, this is our activated sludge system, the MLE I was telling you about. And these are aeration basins. There's 3 of them, 1.3 million gallons apiece. So we have a capability of 3 million gallons stored, basically 3 million gallons of treatment process. I think probably, I'll show you the diffusers in a minute, but after we get through with looking at this area, we'll look at the plant because you can see it pretty good. You know, you can see a lot of things from up here.
Awesome.
Equipment, tanks, and everything else. So,
All right, so
let me show
what's
you.
this item you got down here?
Okay, this is the diffuser system. It's called a small bubble diffuser system. The 2 different ones. This is in these 3 tanks here. This is what they call a bladder type. It's a different. It just blows air through there and makes real small bubbles. The smaller the bubble, the better you get treatment-wise. It's just, you know, the way interspace is. And these are the porous ones on here. They're in the other tanks. So they're to give it just a lot more air. There's probably, I think there's 400 of these in here and about 800 or 900 of those. In this whole
So
tank.
you've got a nice little jacuzzi
Yes, on the
of
bottom of the, yeah, there you go, on the bottom of the
wastewater.
tank. Right.
All right, now I have to ask before we get too much into this.
Okay.
I notice a lot of life rings around here, and has anybody actually fallen in?
No, we've never had anybody fall in. We've got them everywhere. I mean, got them in secondary tanks and everything else. This being as much air as in here, you probably wouldn't survive too quickly. Too long, I should say, not quickly, but too long, because the air would cause you to go to the bottom of the tank, basically. But yeah, we have them all over. They've never been used that I know of. We replace them every now and then.
And this fishing rod looking thing down here,
Oh, that's for taking the sample. We do sample this for our operational part of it. We sample for nitrates and nitrogen and mixed liquor, which is what this is the bacteria that's in here, the mixed up bacteria and rotifers and just all kind of stuff. We do a biological microscopic exam every day on it to see what kind of little critters we have, what little guys are left. We could pretty well tell where our treatment process is by looking at the bacteria, the biological part of it, not just the bacteria, but others. And I think that's probably all we need to know about up here.
very cool.
Okay, to our left is that odor control structure we were at before.
Okay, I see it.
That's just for the inlet structure, that building that we saw where the screens are that pulls the hydrogen sulfide off. These bridge tanks that you see with the bridging across the top, there should be 3 of them here. Those are our primary settling tanks. The reason we bridge it, of course, is we're pulling the odor off of it so that we have an odor problem. And then that goes into that other pack tower, that other white structure in the middle between them. That's again, a bleach solution, taking out the odor, hydrogen sulfide. To the right of that is there's what we call a wind sock. It's a real technical term for a wind sock. Okay,
I got you. I got
what
you.
it is. You have them at airports. It's basically the same thing. It just tells us the direction of the wind. That's the grit chamber under there. That's where the grit is actually settled out.
Now, before we go too far, why do you want to know the direction of the wind?
For this facility, we're reporting consequences, but also in case we were to have a gas problem, a gas chlorination problem. Wherever that wind is, whatever that wind sock is blowing, you want to go the opposite direction, should there be an occurrence. We've never had an event here at this plant in all the time of it's been in instruction. This plant was started in 1926, and it's just, as you can see, it's progressed up and up and up, more technology and everything else. To the middle here is an old empty tank. That used to be what they call a trickling filter process. What that had was they had rocks in the bottom of it, and you actually grew I guess a moss-looking material on the rocks, and that removed some of the settable solids and so forth like that. Then that was pumped to the digesters. Then as we move over further, behind this white, ugly-looking tank is our secondary tanks. That's again, the clarification tanks that bring it to a quiescent area. These don't have any odor, so we don't have to have them covered like the others. To our right, the large eggshell looking thing with the blue top, that's called a thermophilic acid reactor. This is a patented process that we have for turning our sludge into a Class A sludge, which can be used. We could actually spray it on the streets. It's really that there's no bacteria left, no harmful bacteria. There are some bacteria left. We have 131 degree temperature in that. Then that is pumped, the little cylinders can take in the front is actually to blend the waste activated sludge and our primary sludge, because we get sludge from both areas.
Okay.
Then it comes over to these large tanks that are, well, you see I'm painting one of them right now. Those tanks are called mesophilic. That runs at about 98 degrees, 99 in that area, about like our body temperature. Then in the back, the large building in the back is our thickening system. That's where we thicken the sludge that comes from these tanks we're standing on. And then to the right further, I don't know if you can see it or not, but way down to the field, that's straight across that building, you'll see like, looks like 6 white pumps.
They had a little way out there.
That's our final pump station that pumps it all of these 16 miles down to the wetlands treatment system.
Okay.
And that's where it's chlorinated. We have another basin on the other side. We use that. Some of our water is used for the electric company to wash their scrubber units. So it scrubs out some of their sulfur and everything else before they go in the atmosphere.
Well, Bill, I just want to thank you for letting me come out here, take some of your time up, and really see how the wastewater treatment process works. It's been a blast.
Come again.
Well, thank you. I'm going to take you up on that offer. All right. That was a great look into the science of wastewater treatment. As Bill explained, when you send waste down the drain, you're sending it to him and other wastewater treatment plants. This includes the water we inadvertently waste. Did you know that, according to the Environmental Protection Agency, an average family of 4 can use as much as 400 gallons of water a day? That's enough to fill an average-sized swimming pool every month. Through new advancements in the engineering of appliances and regulations set by the EPA for water efficiency, much of the water we formerly wasted is now being conserved. Take your average toilet from the 1990s, for instance. Many of these toilets use between 3.5 and 7 gallons of water per flush, compared to newer WaterSense labeled toilets, which requires 75 to 80% less water. Traditional washing machine models use between 27 and 54 gallons of water per load, but new high-efficiency models can use less than 27 gallons. It is new advancements like these that keep the precious resource of clean drinking water from going down the drain. For tips on how to conserve water and to keep it from heading to the wastewater treatment plant, visit epa.gov/watersense. Now I want to take you to another fascinating recycling facility. Household hazardous waste recycling, located at the Polk County North Central Landfill in Winter Haven, Florida. Hey, Mike, how's it going?
Going all right.
We're here at the Polk County Waste Resource Management in the Household Hazardous Waste Department. Mike, what is your title here?
I'm the lead environmental technician.
All right, and what exactly do you do?
I'm the supervisor for the facility. The facility itself accepts household hazardous waste from homeowners free of charge. We also accept electronics and automotive fluids.
Okay. And you guys sort it? What's the process as you guys receive it?
Once a customer comes in, we'll unload their cart, we'll sort the material, segregate it into the different categories. Whatever can be given away to the public for free, we'll give away to the public. If it's not any good and needs to be disposed of, we'll separate that and we'll process it later.
What are some examples of things that can be given away to the public that can be reused by the public?
Latex paint, household cleaners, lawn fertilizers, good motor oils.
Okay, and that's all sort. And then what happens to the stuff that's not able to be reused? Where does it go?
The latex paint we use as alternative daily cover in the landfill. They spray it on top of the garbage. The paint that we can't use in the landfill will bulk into 55-gallon drums, and our hazardous waste contractor will dispose of it.
All right, so once the cars come in and they stop, you guys unload them. Where does it go from here?
We unload it onto the carts over here.
Okay.
We'll ask some basic information. We'll ask for the resident zip code. If they have up to their limit for a yearly limit, which is 20 gallons, we'll take their driver's license information. I have a database that logs that and will let me know when they came in last. Once we put it on the cart, we'll sort through it, we'll inventory it,
okay,
and put it where it needs to go.
All right, let's take a look at some of these areas.
This is our used automotive fluid area. We have 3 different storage tanks for used motor oil that gets recycled by a local contractor that comes in about every 2 weeks. We also have a tank set up for used antifreeze, and they also recycle that from us.
Okay, so you take both used motor oil and used antifreeze.
Cooking oil, if you have it in your house, we're probably going to take it.
All right, that's great to know.
This is our paint processing area. Like we said, we segregate the material, we put the paint into the basket, and when we can get to process it, we do. We pour up our mineral spirits, our solvents, our used gasoline, which gets taken by our oil recycler.
Okay.
We have separate drums for latex paint, solvent-based paint, roof tar, and grease.
Okay, tell me a little bit about this lampinator.
This is a drum top lamp crusher. What it does is it crushes fluorescent lamps. All the employees here are in the respiratory protection program. We all have respirators. We all wear safety equipment. We're very careful to make sure we don't expose ourselves or anybody else to the mercury in the lamps.
Okay.
If you have lamps in your house, please bring them to us and we'll recycle them properly for you.
Yeah, not commonly known. Awesome. All right, now I see a big machine over there. Can we take a look at that? What is that about?
That is actually a paint can crusher. When we do 4 mobile collection events a year, one in Bartow, Lakeland, Winter Haven, and Haines City. The latex paint we bring back to our facility and we process ourselves. Because it's a large amount of paint, we run it through the paint can crusher, which will crush the paint cans, and it's got a funnel, and it'll funnel the paint into the drums, and we can either use it in the landfill or send it for disposal.
Very cool. And you guys also dispose of electronics?
Yes, sir.
Can we go take a look at that area?
Yep. This is our electronics recycling area. We package it electronics by commodity, the CPUs together, the monitors together, the printers, regular home electronics, DVDs, VCRs go together. Okay. They're shrink wrapped, palletized. When we get enough to load a tractor trailer, I call my recycler and they'll come pick it up.
All right.
The one thing we do different than a lot of other counties here is we demanufacture the televisions and we separate them into the individual components, the circuit boards, the copper wire, the copper yokes, the stainless steel guns. By doing that, we provide a revenue stream for the county and we don't pay to recycle the electronics anymore.
Very cool.
Let me introduce you to our Commercial Hazardous Waste Program Administrator, Andrea Stermer.
Nice to meet you.
Nice to meet you as well.
Andrea, tell me a little bit about the commercial part of this. We saw the household. I hear mention of commercial. What's that?
Yes, our facility recently got approval to allow small businesses to bring their hazardous waste into our facility as well. They have to make an appointment and they can pay for disposal to get rid of small amounts of hazardous waste that they have produced from their businesses. The businesses differ in that they are regulated by state and federal rules on how they have to manage their hazardous waste. They have to properly store it and dispose of it and have records showing that. My primary job is to go out and actually inspect the businesses and provide them with compliance assistance on what they need to be doing with their used oil and hazardous waste.
Okay, and it obviously has to be the same products that are already disposed of here for the household. You can't.
Right.
They can't just bring in random chemicals if it's a chem lab or anything like that.
Yeah,
correct?
there's a lot of chemicals we can't accept, but there's some unique stuff that we probably can't as well. But the standard solvents and waste paint, acids, things like that, fluorescent lamps you saw over at the other area. Businesses also generate those wastes, but there are larger amounts.
Well, that's it for today. Thanks for joining us at the Glendale Wastewater Treatment Plant and the Polk County Hazardous Waste Recycling Center. Join us next time as we seek out yet another Science Quest.